Hello, today we are going to calculate the capacitance of a spherical capacitor. Let's consider this as a spherical capacitor. This is the central core. Let's consider this is the positively charged plate and this is the negatively charged plate. And this is the distance of separation between these two. The radius of this inner core is denoted by Ra and the radius of this surface is denoted by Rb. Now for calculating the capacitance of a spherical capacitor, we will use the Gauss's law to find out the electric field. We know that capacitance of any capacitor is equal to Q divided by V. Q is the charge stored on the capacitor and V is the potential difference. Now these equations will be C is equal to Q divided by V, and solving this same equation for charge Q, we will have Q is equal to CV. Charge Q will be equal to capacitance times potential difference. Now we calculate the electric field. For calculating the electric field, we will use the Gauss's law. We will construct a Gaussian surface and imaginary surface around this inner core, and we know that according to the Gauss's law, the electric flux passing through this Gaussian surface will be equal to total charge enclosed Q divided by epsilon naught. Epsilon naught is the permittivity of free space. So the electric flux, which is E time area, is equal to Q divided by epsilon naught, where this E is the electric field and A is the area from where the electric field lines are passing. Now we are dealing with the spherical capacitor, and this surface is also a spherical Gaussian surface. So the area of a sphere we know is equal to 4 pi r square. So we will substitute the value of this 4 pi r square or the value of area in this equation. By substituting the value of area in this equation and solving this equation for this charge Q, we will have Q is equal to E 4 pi r square epsilon naught. This is the charge Q enclosed by this Gaussian surface. E is the electric field and R is the radius of this Gaussian surface. Now solving this same equation for electric field, we will have electric field E is equal to Q divided by 4 pi r square epsilon naught. So this is the electric field due to the charges in the core of the capacitor. Now we will calculate the potential difference. We know that the potential difference is V is equal to work done per unit charge, or E dot D, or in integral form we will use integral E dot dr. Now this integration is from RA, this is the RA internal radii, and this external radius, that is RB. So integration will be from RA to RB. If we take the integration from RB to RA, then we will take this equation as minus. Also, to avoid this minus sign, we will use the integration from RA to RB. Now we know that the potential difference V is equal to RA to RB E dot dr. Substituting the value for electric field, we know the electric field is charge Q divided by 4 pi r square epsilon naught. Now after substituting the value for electric field, we will have Q divided by 4 pi r square epsilon naught dot dr. Now this integral is dependent only on this r square, so we will have Q divided by 4 pi epsilon naught. Integration is from RA to RB 1 over r square dot dr. And we know this 1 over r square is equal to r power minus 2. Taking the integration of this r power minus 2, we will have r power minus 2 plus 1 divided by minus 2 plus 1, and finally we will have minus 1 over r. Now here this is minus 1 over r. We can write it as 1 over r by just replacing this b with a and a with B. So we will have V is equal to Q divided by 4 pi epsilon naught 1 over R A to B. The limits are from A to B. Now we will substitute the values of limits that are RA and RB. So we will have 1 over RA minus 1 over RB. Now after taking LCM, we will have RB minus RA divided by RA RB. So this is the value of the potential difference V. And this is equation number 3. Now we will substitute the value for this potential difference V in this equation number 1. That is Q is equal to CV. C is the capacitance, Q is the charge, and V is the voltage. Substituting the value in this equation number 1 for the potential difference, we will have Q is equal to C into Q divided by 4 pi epsilon naught RB minus RA divided by RA RB. So this charge Q and this Q will cancel out with each other, and solving we will have this capacitance C is equal to 4 pi epsilon naught RA RB divided by RB minus RA, and this is the value of the capacitance of a spherical capacitor. That's it. Thank you for watching, and don't forget to subscribe easyedu for more videos.